And I give this type of question a name. I find if I, and these names that I give to them, sometimes if you look them up, it's just something I've made up. I sometimes make up names for questions to help you remember them. If we give something a name, then it sort of groups it into your brain as, oh yeah, this is what I do in that situation, and can help us with our memory, can help us with strategies. Sort of like a while back I told you, hey, this is a triangle question. And the reason I call it a triangle is because I'm trying to give you a hint. You should draw a triangle. So I give this one a name. It's a multi-revolution question. And we'll recognize a multi-revolution question when there is something more inside sine, cos, or tan. So this question says, solve sine 3x equals 0 over the domain from 0 to 2 pi. And the reason I call this a multi-revolution question is the first thing that I'm going to get you to do is we're going to rewrite the domain for 3x. And I have 3x in quotations because that's what's in the box in this question. But sometimes it's 2x inside there. Sometimes it's 4x. It can be a half x. So whatever is inside the sine or cos, we are going to rewrite the domain for 3x. Well, what does that mean? They gave us the domain for x is between 0 and 2 pi. So what would 3x's be between? And this is really easy if I just make a simple, I get you to pick a number between 0 and 10. You can include 0, you can include 10. Any number you want. Now, multiply that number by 3. Okay? What is everybody's number between now? Is it still between 0 and 10? No. Everybody's new number is going to be between 0 and 30, right? Because you could have picked 10, so the biggest it could be is 30. You could have picked 0, the smallest it could be is 0, right? Multiplying it by 3 will just mean that if initially we chose something between 0 and 2 pi, multiplying it by 3, does it make sense that your domain for 3x would be between 0 and 6 pi? If 1x is between 0 and 2 pi, then 3 of them would have to be triple everything between 0 and 6 pi. And as far as a visual on our unit circle, 0 to 2 pi is once around your circle. 0 to 6 pi is 3 times around the circle. Hence, my name, multi-revolution, because this example, we're going to go initially 3 times around a circle. So step 1 is we're going to first, if you like steps, step 1, first we're going to rewrite the domain for 3x. Step 2, we're going to solve for 3x like normal, like we would normally solve for theta. So if you had sine 3x equals 0, is 0 on your pi plate? Absolutely, right? If this was sine theta equals 0, you would right away go theta equals and write everything from your pi plate where sine is 0. Now sine is your y-coordinate, right? So you would write 0 and pi and 2 pi, right? If it was just sine theta equals 0, you would write 0 and pi and 2 pi. That is the first time around. But how many times do we need to go around for 3x? We need to go 3 times around. So the second time around, can you see that you would also have 3 pi and 4 pi? And the third time around, you would also have 5 pi and 6 pi. And I think that textbook's being a little bit mean here. Okay? But I may be mean or maybe really trying to make you think that I should always look at my domain carefully. Okay? In the super careful looking at this domain, do you see that they have an equal sign with 0? Sneakily, they did not include the equal sign with 2 pi. I paid attention to that. I don't know if you noticed when I wrote it down and when I multiplied by 3, but what this means is actually 6 pi is not allowed. They have an E error for that. If you include an answer outside the domain, an E8 error, they have to take a half a mark off. Okay? I think in particular, this wasn't very nice of them to not include that equal sign, because we often just have 0 to 2 pi with equal signs with both of them. That's probably the most typical. But again, it shouldn't matter, because if you make it part of your routine to always check the domain of your question at the end and in the middle of your question, then that won't stump you, right? If we make it not part of our routine to check things, then we're going to lose lots of half a marks here and there and in different places. Okay, so far so good. Step 1. Step 1, we rewrote our domain. Step 2, we solved for 3x. Step 3, now we can just solve for x. I don't even have to put it in quotation. I put the 3x in quotation because it can change from question to question. But then, if you had 3x is equal to pi, could you get x by itself? Absolutely. All you would have to do is divide by 3. So we have 1, 2, 3, 4, 5, 6 answers. For 3x, we can get 6 answers then for x. You just have to divide each of them by 3. And if I take all 6 of those answers, divide each of them by 3, I will solve for x. And as a result, right, because originally it said to solve between 0 and 2 pi, when you divide by 3, all of these solutions are between 0 and 2 pi. Perfect. So we had to do the multi-revolution go around 3 times for 3x, but then when you divide by 3 in the end, all of your final solutions are between 0 and 2 pi. Then part B says, can we write the general solution? Well, the general solution, we wrote down the steps for that. First, solve between 0 and 2 pi. We did that in part A. Then, take all of your solutions. So I have 6 of them. I have 0, pi over 3, 2 pi over 3, pi, 4 pi over 3, and 5 pi over 3. I have all 6 of those. Some of them for sure. We could create some shortcuts for this one. In fact, I'll show you some shortcuts later. But for right now, if you solve between 0 and 2 pi, and then add 2k pi to each of them, and say that k is an integer, Well, I think that's one of the nicest sets I've written in a very long time. That'll be your general solution. So we can circle question number 10.